Hello and welcome to week 12 of Synergy 1807, digital preservation. So last week we talked about storage. What are the mediums by which we are going to make sure that these files that we're taking care of stick around for a long time. But we also touched on this idea that, it's not just a question of putting stuff onto storage mediums that are secure. It's also a question about having processes to manage those storage mediums. And typically, we're working with collections that are so big that, you're not just dumping a bunch of files onto a server and saying, I hope that they're all there. I'm going to have some nice file naming conventions and folder conventions and things like that, and that's going to be good enough. Typically, the size gets so big and so complex that you want to have some software to perform those organization functions for you and perform additional functions on top of that. So this week we're focusing on repository software. And in doing so, we're going to look at first how the OIS model is talking about some of these functions that need to exist, thinking about the transformations of the packages that we have over their life cycle, and then following up by looking at some examples of architectures and products that people use to perform these functions. All right, so let's jump into the model here. All right, so we are going to be looking at these archival storage functions, and let's look at our overall system map for how we've been doing this. Now, we have this overall OIS map. We've looked at ingest for the most part, and we started touching on archival storage as the focus for this class. But in talking about this idea of receiving collections and then eventually providing access to those things, hopefully as quickly as possible, hopefully as continually and as reliably as possible, we do need to talk about access a little bit. So we're going to zoom in and we're going to look at this zone, focusing on storage, but thinking about, well, where are the files coming from and where are they going? What are we doing with them after we have them stored? However, as I said, the focus here is on the storage, and I want you to focus on something that keeps showing up on this diagram here. You keep seeing these three letters over and over again, AIP, AIP, AIP. I think it's on this slide at least 5 times, maybe 6 or 7. So it's pretty heavily used. What is the AIP? Well, as we've talked about over the course of this class, an IP is an information package. The AIP is the archival information package. You also hear people talk about this as an AIP. So the question is, what is the AIP? We've talked quite a bit about submission information packages. What is the SIP? What is being brought into the organization so that we decide what we want to keep and what becomes part of the collection? Well, the AIP is the follow-on to that. That is the thing that is what we want to keep. So I'm going to do quite a bit of pulling from the text of OIS for these slides to talk about some of these concepts a little bit more. So what is the AIP? Well, the AIP is something that is created from one or more SIPs that are transformed into one or more AIPs, archival information packages. The AIP has a complete set of PDI for the associated content information. So it has the fixity information, the provenance information, the rights information, the context information, and the reference information that help you be able to preserve that, manage it, and provide access to that information over time. The AIP may also contain a collection of other AIPs that is discussed and modeled later in this subsection. You can go to 4.2.2.2 in OIS if you want to read that. The packaging information of the AIP will conform to OIS internal standards, and it may vary as it is managed by the OIS. Now, I hope in seeing this, what you're really seeing is, again, OIS saying the organization that is modeling its workflow, modeling the standards by which it works, it is defining these things. There is no such thing as an AIP that is universally agreed upon to say, okay, this is what an AIP looks like. These are the components of an AIP. They all have this folder structure. They all have this metadata structure. That doesn't exist. There may be shared ideas. There may be shared technologies that different organizations use or different platforms use, but the AIP is something that is up to the organization to define, and so therefore one organization's ape can look completely different to another organization's ape. And the reason for this is that every organization has its own collection. They have their own collection development priorities, their own preservation priorities, and their own access priorities. And that gets reflected all the way back at the very beginning when we start ingesting things, when we start looking at taking a submission and turning that into a collection. And so, if everything is different all the way through, then that should probably be reflected in what we're storing for the long term and eventually what we're providing as access. So let's focus on that idea of how from this text within the OAS, one or more SIPs are transformed into one or more APEs. All right, so as you might remember from our case studies, we do quite a bit of work in receiving a SIP. And so when you look at the OAS flow, you can see here a producer provides a SIP. They send a SIP for us to receive. We then have quality assurance for it. We send that to this generate ape function, in which at that point in time, that's where we do this transformation, this one or more SIPs to one or more apes, because the errors coming out of the generate ape function are obviously apes. So you no longer see the word SIP in this diagram after that point in time. All you're seeing is ape has been created, and now it gets sent off to archival storage, and its description is being sent off to data management. So to walk through some of those things that we do during ingest, what do we have? Well, we receive the submissions, so network transfer hard drives, however we do that. We then do some quality assurance, which again can depend on the type of submission that we receive. That could be auditing fixity if we have fixity information, auditing the content, doing things like did we digitize to the right spec, or what were the right file formats used according to what we asked for. We can audit the sort of signal quality of these things. We can audit the file naming conventions, the folder naming conventions. We can have lots of rules here. Again, that depends on the type of material we're collecting and the type of collection that we're building. But once we've performed that quality assurance, and again, it does not mean if something fails one of our quality checks that we don't accept the material. So once we perform these checks, whichever ones are appropriate, well, then we go to that generating the ape function, and in there we can remove files. If there are files that we do not think are important, we are under no obligation to preserve those files, depending on the contents of our donor agreement. But we can delete things if we need to delete things. We can add additional PDI. We can create fixity information if that fixity information did not exist. So a very common thing to do is to create a checksum for the first time because we got something on a floppy disk, and of course that floppy disk doesn't have checksums associated to it. We can convert files. We can say, hey, we have a bunch of MOVs and we'd rather have MKVs, or we'd rather have MXFs. We could do a lot of different types of conversion there. That again is up to us to decide. We can generate derivatives, for example, creating MP4s from any videos that we received. We can combine SIPs. So we can say, well, we got two different hard drives filled with material, and we've decided actually all of this material should be treated as one large body of material. Okay, so we'll just make one big ape out of those two SIPs. We could also split SIPs. We could say, hey, we got a big hard drive and decided each folder on this hard drive is something that should be tracked separately, described separately, managed separately, and so therefore we're going to split that SIP into multiple apes. So we can do a lot of division there before we send it over into archival storage. So that's one part of this SIP to ape transition, or this one part of this information package transition that we should be aware of. The other part of the information transition that we should be aware of coming through this archival storage function is what happens to the ape after storage. We are storing these things, we're preserving these things so that they can be accessed at some point in the future. So therefore, what happens? So what do we do with the ape? How do we make that accessible? Well, when you look at a diagram, you'll see that in the access function, we stop talking about APEs. Just like how SIPs disappear with an ingest, with an access, APEs disappear and they get replaced by something called a DIP, a dissemination information package. So what is a DIP? Well, a DIP is created in response to an order. The OAS provides all or part of an APE as part of that dissemination of information package. That DIP may also include multiple APEs. It may or may not have complete PDI. It may be present, it will always be packaged in some way. It may have descriptive information added to it. But as you can see in every single one of these sentences I'm saying, there is a maybe. It is, again, up to our definitions, up to our decisions to say what parts of this thing do we want to provide to the consumer, what parts does the consumer actually want. There is a lot of information that is important to us managing a collection that has absolutely no value to somebody that's looking at a file. For instance, provenance information, saying we use this deck, this signal chain to create this file. Man, that could be useful to us. It is very, very rarely useful to somebody that just wants to see the contents of that video file. So again, OAS is just giving us this gigantic set of options that we have to choose from, or it's saying we should choose from. We should have some ideas of what we want to choose. But the core thing here is saying, well, you've stored something. The thing that you store does not have to be the thing that you provide access to. And I need to reiterate that because that's, I think, a common complexity in some of these architectures that we look at. Like when we're talking about doing digitization and we create this massive preservation file and this much, much smaller service file, well, what's going on there? Like, why do we have this massive preservation file? And why do we have this tiny service file? Especially when the preservation file could be so big that it's hard to download. It could be in a format that people aren't familiar with, in a codec people aren't familiar with, and the service file serves 99% of use cases. How do we handle that? How do we manage that? Well, OAS says, great, store both of them. If you think both are part of the APE, store them both. And realize that in most cases, your dissemination information package is just going to be that access file. You don't have to give every single user this massive preservation file. If they don't want it, they don't need it. So don't waste your time trying to force it on them or trying to build an architecture that's constantly delivering preservation files. Think about what's useful and purposeful for your system. So looking at this diagram again, as I mentioned, once we go into the archival storage function, it's all APEs. AIP is at the end of every single arrow. You receive the data, it gets stored onto media. Again, OAS doesn't define what media. We have to decide our plan, as we were talking about last week, and then we provide the data over into the access function. And you'll see that that data is provided over to a function called generate the DIP. So in access, that is where OAS says that the dissemination information package is created, and it is created based on archival information packages that are sent to it. So let's talk about that generation of the DIP. What happens at that point in time? Well, OAS gives us another huge block of text, and so we're going to break this down piece by piece. So looking at this overall, you can see as you're looking through it, there's, to generate this DIP function accepts a request and then retrieves an APE. It does some work. That's the vast majority of what's happening. And then at the very end, it says this function places the completed DIP in response, the completed DIP response in the temporary storage area and notifies the coordinate access activities that it's ready for delivery. So we are taking something, we're performing work on it, and then we're saying this thing is ready for access. Now, the first part of that is a very simple workflow. And when they're saying, what could happen when you're providing access to a DIP? The first part is to say, well, could accept a request, retrieve that APE, may move a copy to a temporary storage area, and then obtain some descriptive information needed for the DIP. Like, that's it. Just make a copy and say, okay, we have it all, and then provide that to a user. So a very simple, something you could do if you just have a file server. You could go find the files that you want, make a copy them over to some sort of different device, a workstation or something like that, and provide them to a user. However, we can do transformations on this information. There's quite a few different kinds of transformation that OAS even outlines, and it doesn't try to say that this is an exhaustive list. So things that you could do after pulling your files out of your archival storage and thinking about access to them. Well, if you need special processing, the types of operations which may be carried out include statistical functions. Now, this being written by space data scientists, they're going to think first about statistical functions. They're thinking about, like data coming back from space probes, as we talked about a long time ago. But I think more interesting, subsampling in temporal or spatial dimensions. Again, this sounds like a scientific term, but think about this as clipping. If somebody says, hey, I only want 5 minutes of this extremely long video at a very high quality, well, that's called subsampling in the temporal dimension. You're clipping it down. You can also think about this in spatial dimensions of cropping an image or things like that. We can have conversions between different data types or output formats. One of the things that we see very, very commonly is we store our preservation files as MKVs with an FFV1 codec. Very often we find that people that need access to the highest quality of files that we have are asking for MOV formats with a ProRes codec. So we will do that conversion and we'll say, okay, cut that over there, and now you have something that you can work with. Other specialized processing, like image processing, we might sweeten something, we might clip the noise or normalize the volume levels, things like that. We could insert DRM information, put watermarks on there, or put DRM into the codec so that it is encrypted for use only to specific people. We could filter out personal data if that's necessary for something that we need to do, especially, do that through clipping or obscuring things within the file. Lots of different transformations that we can do from the files that we have in providing them to somebody else. And the way that OAS writes this text is that they're always thinking about this as something that is in response to a request. So they're saying you could do this on demand if you really want to. Everybody wants something a little bit different, and you could have a service that could accept those different types of requests and be able to provide something in response. However, the text of OAS also makes clear that most people kind of want the same thing. If we're talking about digitized video collections, most people want a service file, and it's probably something that looks like an MP4, H.264 codec. Not that they know these words themselves, but they want something that plays in their browser. So it says, when you are generating the DIP function, it's worth noting that in some implementations, the APE content or the DIPs could be kept in temporary storage for ready availability. So that's something that we see extremely, extremely commonly, that what we end up doing is saying, well, most of our access is pretty much to the same file, and most of our access is to a very specific generation of a file. And so what if we just, have an entire temporary storage area where we keep those files ready to go? You can see people define their APEs a little bit in this way as well, to say, well, I have this preservation file and I have this service file. I don't consider the service file part of the APE. I consider this actually just a service file, something that if I lose, I don't care. I will generate a new service file from the original preservation file that I have, or the edit file that I have. So I'm just going to keep a single copy of that in some sort of almost like semi-permanent storage area ready for access and usage. And thereby, if somebody ever asks for access to those APEs, most of the times I'm just going to send them to the service file. And if I ever lose those service files, I don't really care because they're just kind of temporary. Whereas the actual preservation files, I'm going to put a lot of effort managing them and taking care of them and making sure that they are viable for a long time. So again, OAS, lots of flexibilities here, lots of options that we have. The core thing that I want to reiterate is we have 3 types of information packages, and the contents between them vary pretty drastically, and we need to be thinking about that in terms of what we're keeping for the long term. So we have a submission of information package. That is the stuff that we receive. It contains packaging information. That's all of our packages and contain packaging information. It may or may not include the content or the PDI. So this is incomplete. We're getting kind of the raw material. We might need to do some transformations to that material in order to say, like, yes, this is the thing we want, because the thing that we want is the archival information package. It contains a complete set of the content information and the PDI. So we go, okay, we got the raw stuff, and now we're going to do those processes that I outlined a few slides ago to say, okay, this is the thing we want to keep. And then from that thing that we want to keep, we produce things that other people want to use. And those things that other people want to use only have a vague relationships to the thing that we're keeping. They could be all or part of one of these APEs. They could be a collection of APEs. They could contain only content information. They could contain some PDI, all of our PDI. They could contain some descriptive information. It doesn't really matter. It's up to the user to ask, here are the things that we want. So we have some very, very drastically different things. On the outside, the 2 things where we're receiving and we're giving, those really take shape based on specs that we're working with, that we are an interface between outside parties and we're negotiating what is the thing that we want to do. The thing on the inside, the APE, that is something that we define, and we get to say, here's everything that we need to know about an object so that we can be ready to produce something that somebody wants to use in the future. All right, so let's look at just 2 abstract views of what this lifecycle can look like, this SIP-AIP-DIP thing. So because these are just conceptualized things, let's just look at some flows. You could have a workflow in which you take a SIP. We'll say, your digitization vendor digitized a tape. They sent you a package according to the specifications that you have. You say, hey, great, that's perfect. You did it exactly the way that I want you to do it. So actually, that's an APE. That's the thing that I want to store because that is the way that I've built my workflow. It all works out. I'll store that. I'll put that into my storage hierarchy. I'll monitor it over time. At some point in time, somebody will come into my organization and say, do you have the files for this tape? Did you digitize it? Can I use that material? And you say, yeah, I do. They're sitting on that server. Let me just go grab a copy, because you're just going to get all this information. You're going to get exactly the thing that vendor sent me, just a perfect copy of it. I'm going to provide that over to you. And that's it. Like, you could have that workflow, and that could be a perfectly OAS compatible workflow. It could make everybody happy and something sustainable, and that you do. And yeah, that works. That's fine. You could also have a more complex workflow. You could have something that happens along the lines of saying, like, hey, I got 5 things. So for instance, you are working with a archival collection. They created a bunch of materials, and some of those materials are stored on some different digital media. So you got 5 burned CDs that were burned sometime in the 90s. Well, you bring them in and you look at them and you figure out, well, 2 of these CDs are just, I don't know, MP3, pirated CDs or pirated music of stuff that they like to listen to. It actually doesn't matter to the collection, and it's not something that you really want to keep. So chuck those out. You don't really want that material. But the other three CDs, okay, maybe that's like a video project that they were working on, and there's component materials that all relate to the same thing. They were just split across 3 CDs because they didn't have enough capacity at the time to put into one place. And you say, well, okay, I want to keep these things. These are important. This is something that will be used again in the future. So I'm going to rip all the files off of it and combine them into a single archival information package. You store that thing, and then at some point in time, somebody comes in and they say, hey, I saw that you have this collection. I'm pretty sure that there is a video file in it. There is a final produced version of this project that they created. Can you send me the final version of it? And you go, yeah, I can. I have a single file in this large ape that I created out of this video project from these CDs. I go find that file. I make a copy. I convert it to like MP4 or ProRes MOV or something that this person asked for. I call that my DIP, and then I serve it to them. And yeah, that's great. It's far more complicated. There's far more staff time involved there. You have a more complicated system. You have to have more tools to accomplish this. But it does serve a more specific need, and it handles a very different kind of a use case. So, both of these workflows, totally valid. It's something that you need to think through. And these tools of SIPs, APEs, and DIPs, they're more, I would say, tools to help you conceptualize the things that you want to do and to conceptualize, okay, well, how do I want to manage this material over time? And I say that in part because, as I said before, one of the core things that we run into is, especially in digitization workflows, is we get these preservation files and we really want our users to have access to service files. And there are very different use cases for when you have access to those different materials. And as I mentioned last week, the definition of the information package is that it is stored either logically or physically together. OAS doesn't tell you exactly how you want to run your storage between hot and cold media. Gives you basically a lot of freedom to say what meets your use case. Okay, build your system to work like that. So there's this managing storage hierarchy function. And one of the things it does is it says that you position the contents of an ape on appropriate media based on your policies, your statistics, and your directions. That could be online, offline, nearline, or hot, cold, kind of warm storage, either way. But what you can do is say, okay, well, the MP4 version, the service file version, I want that one to be always accessible, easily accessible, something I could even build a website on top of. The preservation file, well, that's less important. I could put that in offline storage and only call up on it every once in a while, whether it's to check the fixity of the object or because I got a special request and they needed the highest quality that we had access to, whatever it is, that's a little bit different. So keeping in mind these ideas of all of these things are just concepts and you can kind of twist them to meet your specific use case, but they are useful concepts so that you can bracket those decisions and you can say, okay, the issues of a SIP and the storage of a SIP are very different than the issues of an APE, are very different than access issues and access to DIPs and with the contents of a DIP. And so you can think about those a little bit and you can start thinking about, okay, well, what is the software that helps me accomplish that? What are the larger systems by which I can help manage the SIP to APE to DIP transformation, which can be very simple or it could be very complex. And the more complex it is, the more help we're going to need to automate that and perform that work at scale. So what are the requirements for this software? Well, you need software that's going to understand the objects that are in your package, especially the PDI content versus the content information. You potentially want to automate some of those ingest functions. In this class, we've done by hand a lot of command line work. We've tried out a lot of tools. A lot of those tools could be run by another piece of software. You don't have to be typing on the keyboard yourself. So maybe we want our software to do that. We want that software to do that hierarchy management function, to store the files on the appropriate media. We want it to manage the relationship with any descriptions that we have. We want to provide an interface by which we can retrieve those files and provide them to a user function. And potentially, we want that software to be able to transform the contents of an APE into some sort of dip for somebody to use, whether that's, a format migration or extracting specific files or things like that. So we're going to dig into that next.